Okay, hello everyone. I'm Mihaela. I'm a software architect at Systematic. I'm working within the defense department here in Systematic, which is one of our most sensitive and critical business units. And today I'm here to present a recent experience that we had and extended over a couple of releases. So I basically share our journey of moving away from Java 8. But before I actually get started on what we have done and what challenges did we have, let me ask you a couple of questions. Is there someone still using Java 8? And even though I'm afraid to ask something even older than Java 8? No, nobody, but Java 8 I saw a couple of hands. Okay, unlucky person. How about Java 11? Okay, a couple. Something newer, Java 17? Almost everyone. Okay, a tough question. Is there someone using Java 21? Either upgrading from an older version or directly starting using it? Okay, so there are a couple of lucky persons, and I guess that all the others wants to get to that point. Isn't it right? Perfect. Now that we all know what Java versions most of us are using, let's start our experience here at Systematic in moving away from Java 8. And I will actually start by providing you a little bit of context of what is the nature of our project so that you can understand the complexity and the importance of the task for us. And also some details about the architectural part of our application, how everything looks, so that you see the big complexity that we have of a lot of things to migrate. Afterwards, I will try to ask a reasonable question: why? Why to start a journey like this? Why do we want it to migrate? What were the main reasons that forced us to go into that direction? Afterwards, I will share as well the bad things, what were the challenges that we had, because there were plenty, and some of them made us postpone the release of this migration task, one release, so we had quite a lot of problems in moving away from Java 8. I will share those and also how we managed to overcome each of them. Also, what's next for us, because when we started this, to move away from Java 8, our target was Java 17. That was the latest long-term support version that appeared at that point. Until we managed to complete 21 was already there, so there are quite a lot of things on our roadmap to move forward. And at the end, we'll have time, hopefully, for some questions and answers. And as you already know from the other presentations, you can scan the QR code for the Slido part, and we will take the answers at the end. So, when I presented myself at the beginning, I said that I work at Systematic for the defense department. So this means that the software we are building is meant for these guys that you see in the pictures, which are working, they are doing their task, their jobs, either on land, on sea, on air, or from a command and control centralized server. So it was vital that we don't break any functionality, even the smallest thing that they use in the application. Just for our Java migration process. And this was the business part. Now, let's look a little bit of how our architectural looks like. And I will just provide a few boxes, a very, very simplified version of what we actually have. And I will start with a very big Java 8 monolith application. We started from here. And this monolith application has its own roadmap in terms of being migrated, because at the beginning, we had 3 monoliths, actually. We had a .NET one, we had a Scala, and a Java one. And from 3, we wanted to have just one programming language for all of them. And so far, we managed to get rid of that .NET monolith. And this Java monolith also is being in the process of being modularized. So we are extracting functionalities and developing new features directly as microservices. So this huge thing needed to be migrated, along with all the others monoliths. But besides that, we have quite a lot of Java plugins, Java 8 plugins. And all of them are either created by us, such as a proof of concept for our functionalities, or they are created by our integrators, because we have a lot of APIs, we have a lot of code exposed that can be used either on the client side or on the backend side. And our customers are the integrators. Most of them developed their own plugins that are deployed on top of us. So we needed to ensure that we migrate everything and that they are also willing and capable of migrating their own so that they can be compatible with our application. And last, as I mentioned, we do have a lot of Java microservices. Those that were either created from scratch when we had to implement new functionalities, or that we started to migrate from that Java 8 monolith. So just by looking at these few boxes, there are quite a lot of things to migrate. And we need to take care of any issues that can appear so that we don't break any piece of functionalities. And just looking at this, it means that we have a big effort, and we have a very important question now. Why? You know that word. If it works, don't break it. So why should we start on a roadmap like this? Why should we migrate from Java 8 and move to something else that may bring us some value, but it can also bring us some challenges, some problems with our application? And I will list a couple of reasons, list that we compile so that we can start on this roadmap and to also convince our stakeholders that we need to get that part, because as we all know, we need budget and time and to put it on our roadmap, and business details like this that are important and are real in an application, in a project. So we had to provide a list of reasons. And first of all, we wanted to improve our way of working. We wanted to improve our way of developing. So any developer wants to benefit from all the newest language level enhancements that appear, those that will help write clearer code, that will help write code that has less risk of introducing problems in the code. So in other words, those that will help improve our entire code workflow experience. Besides that, we wanted to benefit from all the security fixes that appeared in newer Java versions. So all those security fixes for the vulnerabilities for which, along the time, we had to make a lot of workarounds to fix them, to address them. So we wanted to benefit from all those security enhancements that will help with increasing the data protection and integrity of our application for our customers. And there are even more reasons. We wanted to benefit from all those new APIs and functionalities that are embedded in newer Java JDKs. And also, we wanted to benefit from all the performance improvements that were brought to newer Java versions. Those improvements that could improve our application responsiveness for our customers, that could run things faster, because there were a couple of new changes in terms of garbage collectors. There were new garbage collectors introduced, and we wanted the chance to test all of them and see if they can bring some value to our application. And last, but it's last only on my list, there are plenty more of reasons for which everyone should start migrating from Java 8 to any newer Java version, either it's 17 or 21. And that's the ability to update our other infrastructure components. And I will actually start providing you more details about this one, because it was important for us to decide the Java version that we wanted to get. And that's because in our development environment, we are using Wildfly as our application server. And because we had a very old version of Wildfly, and obviously we wanted to update it, we started looking at Wildfly 29, and our analysis, well, it said that it is no longer compatible with Java 8, the one that we were using. And it requires at least Java 11. Okay, from 8 to 11, there aren't so many changes. That could have been maybe an easier update. But we also started looking at Spring Framework. For all those microservices that we started writing, we wanted to use Spring Framework 6, so Spring Boot 3. And our analysis also enhanced the fact that this is also not supported with Java 8, and it requires at least Java 17. And as Spring did, there are a lot of other dependencies or applications that depend on Java and which started to require at least Java 17. But for us, these two were the most important, because those were on our roadmap to be migrated. And just based on this, we decided that we really need to go to Java 17. But there appeared another question. We had Java 8, we wanted to get to Java 17. But between these two versions, there are almost 10 releases of Java. So what got changed? What are those benefits, those functionality enhancements that could bring value to us? And we started to compile and test some of them, those that we were using in application and could have been improved. And I will share some of them, but please know that this is just a limited list. There are plenty more of changes in between Java 8 and Java 17, not to mention till Java 21. And I will start with someone that we needed, at least temporarily, as a workaround. That's the multi-release jars functionality. Actually, this wasn't implemented that far away from Java 8. It appeared in Java 9, but we discovered it when we wanted to get to Java 17. And this multi-release jars functionality allows the possibility of a class to be completely replaced at runtime. So this means that we can have multiple instances of the same class, but compatible with different Java versions. And let's take an example like I have this illustrated in the slide. We have two classes, A and B. And let's assume that they were both written with Java 8, with some old APIs. And in Java 17, we have newer APIs, something that can improve the performance of these two classes. But as mentioned, we had some integrators. And if they were using our APIs and they weren't able to update at the same time as us, we had to provide them a workaround to still keep using those APIs not to break the backwards compatibility of our application with their plugins. So this feature for us came very handy because we can have the same two classes, A and B, implemented with Java 17 with faster APIs, faster performance, and just place them in a meta-inf version 17 directory and can have the same for multiple versions. If we have, for example, if we need 11 as intermediate for someone else, we can just have them placed in their own directory, and the compiler is smart enough, will know, the class loading mechanism will know at runtime what Java version we are using, and it will load those classes. And this was just the first example. Let's continue with something else. And that something else was represented by the switch expression. And honestly, we have plenty of them in our code. How about you? All of us, definitely. And let's take a simple example with the old way of writing a switch. So let's assume that we want to extract the quarter based on the month number. What does that mean? Well, we have 12 months. This means 12 case expressions, plus a default case expression in case we are not providing a valid number. That's easy. We got used to this. But you can already see we have month 1, 2, 3, January, February, March. They are all in the same quarter. And this is an easy example. How about if we would have some big logic in there? We could have ended up with a lot of duplicate code. Well, with recent changes, now we can have case expression that contains multiple values. So we can group them, and the group of values will have the same return statement. And as you can see, we already simplified the previous switch that we wrote. And now we ended up with 4 case expressions with grouped values, and that default is still there. But we can improve even more. For example, if we want to return something but also execute run an operation, we can use the yield identifier. This is old, it's not quite new, because it was supposed to be used, not supposed, it was used in the multi-threading part, but it can now be used for switch in code blocks to still return a value and perform some operations, like I have here in this example. And there is even more changes for switch. It can be used on enums. And an enum is a finite list of values, so the list is exhausted. And let's take our month enum as example. And you can see below the switch expression only has those 4 cases based on the switch, based on the values from the enum. So we no longer have to write explicitly that default operator. And if we were to invent a new month, a 13th month, we will be notified that we need to also handle it in switch. the default operator, we no longer have to write it explicitly, but it's still there in the bytecode. It's automatically being generated. But at least this is a simplified way of writing the same switch. Looks better, no? Okay, let's continue. Another functionality, another enhancements that were made are for instance of operator. And I'm sure that all of us have at least once written a validation, like if a specific object is an instance of a specific class. In that case, like I have here for circle and rectangles, then we will need a variable of that type to cast it to that class type and only then be able to perform operations. Well, now instance of had been enhanced enough so that it can both test that parameters and assign it to a binding variable of that proper type. So we already have a simplified way of writing this. We already have that variable circle that we can use in the context of that switch directly to perform the operation. And if we were to combine these two functionalities, these two enhancements that we have seen for switch and for instance of, we get something called pattern matching for switch. And let's take another example. We have here a validation for a specific object of type collection, and we want to test it against a stack, a linked list, and a vector. And based on which type of the class it is, it will perform some operations. Then this is the old way of writing with instance of. And we've just seen how we can simplify this, but we can also use something called type pattern, which allows the flexibility when defining conditions for switch cases. And we can use that example directly in the class, in the case expression for the switch, as you can see here. We have a case for stack, which applies an operation. We have a case for a linked list that applies another operation, and the list can continue. What if we want to perform an additional validation? For example, if we want to check if a specific object is a linked list and it has the size greater than 5, then perform a specific operation. We have something called guarded pattern now, which allows us to both test if an object is an instance of a class and also to have a Boolean validation in there. And there's more, obviously. We have parenthesis pattern. If we want to have a lot of validations and to group them however we want, as I have here in the example for a vector. We can do that now. But let's move a bit away from switch and instance of, as we have seen plenty of enhancements made, and have a stop at text blocks. Well, these are multi-line text which are present in all the projects, either for license files or for HTML code or for SQL code. We have plenty of them in our application, and I'm sure everyone has them. And let's look a bit at how it used to be in Java 8 and older, and how we can use it now. And the first example from the top, it's an HTML in the old way, and there we have a lot of escape sequences, the plus operator at the end of each line, the codes at the beginning of each line. So a lot of boiler code that we need to write for a simple HTML file. HTML code doesn't look like a valid HTML code. But let's look a bit at what was changed, what was improved for text blocks. And the second example, as you can see, we have 3 codes at the beginning, 3 codes at the end, and that's it. What it is inside them really looks like a piece of HTML code. So this simplified a lot how we can write HTML codes in our application. And similarly, we have for SQL code. And in our application, we have plenty of native queries. And the first example is not something that we can simply copy-paste in an SQL editor and run it and check that we have written a valid code. But the second example, without all the escape sequences or the escape characters, 3 codes at the beginning, 3 codes at the end, and that's it. What we have in the middle can be copied directly from a SQL editor, and we are certain that we don't have errors, or at least the risk to introduce errors is lower. Okay, moving next, there were a lot of changes in terms of APIs. We have new APIs for stream, you have new APIs for string, we have new APIs for arrays, and the list can continue. Let's look a little bit of new API for stream, for example. Now we can use the toList API. It's it's easier with it to convert from a stream into a list instead of relying on the collector to stream at the end to collect everything, to transform it, to convert into a list. The result is an unmodifiable list, but it's pretty handy to get to this step. I mentioned there are a couple of more APIs. I stopped at another example for indentation. The intent method can be used to add or remove white spaces from the beginning of the line to adjust the indentation for each string that we have. And here you can see something for JCon for this day. What is tricky here is that those indentation that is being added does count for the string length. So in case you need to count just for the correct characters, you can't just use this method and that's it. It will add those spaces that were added. More for string, there was another method called transform, which can be used to call a function on the given string. And I have here an example for a simple concatenation, but another good example, and it was useful for us. You can use it to apply camel string from the utils to transform, to convert directly those strings. That could be another example. Okay, and I did mention that we also have some new APIs for arrays, and this can be just a simple example, but we had some loops in the code that we could simplify, and we noticed this part as well. We now have something called mismatch, and it simply returns the first mismatch between two arrays. But instead of looping through two arrays, comparing each values to find that first occurrence, we can simply use this method now. Okay, moving forward. We now have something called local variable type inference. So in other words, we can use var in Java, like in many other programming languages. So we can use it to define variables without specifying the type. And the compiler will infer the type of that variable using the value that was provided. And here I have a simple example of a string. So instead of explicitly declaring that variable that is of type string, we can use var, and the compiler will take care of the rest. And let's move to something hopefully more interesting, or at least it was for us. We can now use records. So let's look at this example that I have illustrated here. We have public record min-max, int-min, int-max, and those bracket. So just with this line, with this definition, we have the getters, we have the constructor, we have the toHash, the equals, the toString, so all those boilerplate methods that we would have written for a min-max class or had the ID generated for us, obviously. And we can even extend it more. For example, if we want a validation like I illustrated here on this slide, if min is greater than max, then just throw an illegal argument exception or something even more correct for this scenario. Or if we want to determine the geometric average or some other calculation, perform some other calculation with our min-max example, we can definitely extend this class. We can have that compact constructor for min-max that I showed you, and a lot of other methods. But what are records? I'm still telling a lot of them about them, but without actually defining them. So records are immutable. They are final. They can be considered data holder classes or tuples with a type or tuples with a name, if we want to call them like that. They can be very useful if we want to return multiple values at the same time, or for DTOs, but not for the JP entities, because those still needs to be mutable, while our records are not. Okay, and besides records, we also have something interesting represented by sealed classes and interfaces. And I will start again with an example. We have a definition like public sealed class device, premise, computer, and mobile. What does this mean? It means that the device class can only have two implementations, computer and mobile. This means that we are closing the class here inheritance with this definition. And those two classes that I mentioned about, computer and mobile, can be on their own either final, so it cannot be subclassed further. They can be also sealed, and this means that we need to provide other classes on the permits list, those that can be implementation for them, or they can be non-sealed. So this means that we end the parent-child hierarchy here. So these seal classes, and the same applies for inheritance, are very helpful of defining permitted subclasses for classes and interfaces, and are getting us in the point of defining a fine-grained inheritance control in our application. And I think that so far I've listed quite several functionalities and enhancements that were made. But what's the catch? Can we simply put in Gradle or Maven or what we are using in our application that from now on we have Java 17, build everything, and that's it? The answer is no. Unfortunately, no. And that's because there may be a lot of new functionalities, enhancements, new APIs, new security, and details like this added, but there were also stuff removed. So we had plenty of challenges because of this. First of all, we are dealing with missing libraries in newer Java versions. We are dealing with removed APIs in newer Java versions. We are also dealing with out-of-date dependencies and also with deprecations. And for a Java migration task, we need to address all of them so that everything to work at least same as before. But the end goal is to have something that works better, not to break existing functionalities. And let's look a bit of how a Java migration process can look like. A very, very simplified version. So let's assume that our Java 8 application has 4 libraries, only 4 direct dependencies. So these 4 dependencies need to be migrated. But there aren't just 4, because each of these 4 dependencies have their own dependencies, which have their own dependencies, and I just draw here 27 libraries. So just in my example here, but in a real scenario there could be plenty more, maybe hundreds of dependencies. So all of them needs to be migrated. And let's assume that 26 from my example here are fine. They can be upgraded without any problems. But it only takes 1. If it wants to be displayed on the slide. It only takes 1 to block your entire Java migration task. And that one dependency that cannot be updated can be something vital for your application, something that the entire functionality depends on, or it can be something that small that you weren't even aware that you are having it in the application. Well, this is exactly like something like it happened for us. And that was because starting with Java 15, Nation was removed. It was announced as being deprecated in Java 11, but we ignore it. We said that we are in Java 8, we don't want to upgrade at that moment, we will continue to use it like it used to be used before. But we were at that step in which we wanted to perform the migration, so we needed to find a solution for Nation. Has anyone heard or used Nation? Okay, a couple of you. Well, we were using Nation for our collaborative text editor. Imagine that we have Google Docs embedded, built in-house and embedded in our application for military documents. They are used by multiple military guys in the same time to gather orders from them, to respond to some requests and details like that. And this is a collaborative tool, so we have plenty of algorithms so that every change is live streamed to every user that is connected, and everyone can access, view, and edit at the same time, and everyone sees everything. So we were using Nation for this. And the collaborative text editor is something being used quite often by our customers. So it wasn't something that we can get rid of and said, okay, we will move to another version. We don't care about this functionality, let's remove it. No, we couldn't do that. And I mentioned it was removed starting with Java 15 because it is based on the implementation of ECMAScript. And all the changes that were made in Java in the past years, well, it made it hard to be maintained, and they decided to remove it. So we needed to find a solution. Luckily, there were alternatives, and we started to consider all of them, to test all of them, to make some analysis for pro and cons, what we can use and what not. One stop was at GraalVM, and I think we saw some presentations even one today for Graal VM, but this was too complex for us. It would have introduced a lot of complexity in our application. It was more than what we needed just for our collaborative part. And we didn't want to get one day in the same situation like it was for Nashorn. And another alternative was to still continue to use Nashorn because it was removed from the JDK, but it was moved to OpenJDK. But unfortunately, even though that would have been the easier solution for us, the license part wasn't good for us because being in a defense department for military software, we couldn't use that license that it was in the OpenJDK. So unfortunately, we couldn't start using, to continue to use Nashorn from the other library. So we needed another solution. And for us, that solution was to build a solution in-house. And because of Nashorn, we had to stop at Java 11 with our process. So we took an intermediate step to deliver something. We stopped at Java 11 so that we find the solution for Nashorn and be able to continue to migrate to Java 17. So as mentioned, we quite had a lot of problems with this migration. This was one of them and the most important. And as mentioned, we built a solution in-house. We got rid of Nashorn, so we got rid of a third dependency of our application. And the performance was better with our solution, honestly. Okay, let's see what other problems we had. We had problems with Lombok. And that's because the strong encapsulation was implemented, and this means that we can no longer use the JDK internals. We started having a lot of cannot access, different classes, and many other similar errors. So we had to rewrite some pieces of the code, and we also had to update Lombok. It worked better with that version for us, 1.8.22. And as it happened for Lombok, it happens for Mockito, our testing framework. But the situation was even extremely more difficult. And that was because we were having version 1, which worked perfectly with our Java 8. We didn't have any problems with it. But to get to Java 17, we had to upgrade. And the difference was quite huge in terms of versions and in terms of what was actually changed. And we spent weeks fixing unit tests because there were hundreds of classes that were failing. So we had to pick every piece of unit test that was failing. We involved all the teams, each team that owns different areas, to handle their own test, not only the team that handled the migration. And let's look a little bit of some of the examples that were changed, why we had such big problems with unit tests. Well, a lot of measures, a lot of methods got their name updated, so we need to address them. It may be easy changes, it is an easy change to do, but there were hundreds of classes, and we needed to do this for all of them. We had not only classes that were removed, methods that were removed, we had methods that got their parameters in terms of order changed, so we needed to address those as well. And something that I found funny when I saw it in our application, for example, we were using any int, which was that flexible to test any type of data type. And we were using it, for example, with a long, which obviously doesn't work. It's not that flexible anymore. So we even had to make this kind of changes. And these are just a few examples. As mentioned, upgrading Mockito and fixing our unit test was a task on its own. And it took us a lot of time. But this wasn't the only problem. We also have had problems with the Java EE modules that were removed from the JDK. Luckily, they were removed to Jakarta. So we had to replace those dependencies, those import statements, and to move to this to continue to have what we used to have. And there's more, obviously. We are also dealing with deprecated language functionalities. And we started to look better at this so that we won't end up in the same situation as we did with Nashorn. And these are just a few examples that we had to deal with. For example, the new instance is replaced with the class get declare constructor new instance, or the constructor of the primitive wrapper classes, such as the new integer, is now replaced with integer value of, And the same with local constructors, and the list can continue. So there are several deprecated language functionalities that we also need to address in our process of migrating. And I think that I shared a lot of our challenges as well. As mentioned, we postponed the release, the migration with one release. We had to make an intermediate step at 11 before getting to 17 to fix everything. But once we got to our target, we started asking what's next. Because as mentioned, when we started, 17 was the latest long-term release version. But in the meantime, Java 21 appeared last year in September. And we started to look when are the next releases. And hopefully we won't wait until September 25 when Java 25 will be released. So we already started looking at what's next. And for now, our target is Java 21. We want to get there, obviously, to continue to update in the future. But for now, we are looking at what's new in Java 21. And this seems to have a lot of new functionalities as well. For example, we have virtual threads that we want to have the chance of testing to see if it can bring us some additional value in our project. We also have changes in terms of sequenced collections, new collections added. Java 21 brings changes for the records. We have records pattern. We have some other functionalities in preview, such as structure concurrency, scoped values, string templates, and unnamed variables. And this is just a simplified version. This is just a simplified list of what's new already in Java 21. And we want to get to the step in which we will have them in our application. And I think it's time to sum up my presentation, and afterwards we'll have time for question and answers. I can make a statement, a summary to simplify everything, that upgrading from Java 8 takes time and effort. Depending on the project, it can be a very time and effort consuming task. It can have a lot of issues. You can have a lot of challenges. I shared some of ours, but it is required because Java 8 is unmaintained, because newer versions bring performance improvements, brings new language level enhancements, and we already seen a couple. We have security improvements in newer Java versions, and a lot of new APIs and new features, new libraries, and so on. Obviously, the road to getting to a newer version has its challenges. I mentioned Nation, so maybe something similar can happen in other application, but I think is necessary. At least we consider it like that, and we were happy at the end. And I think that is all from my side. And now let's see if you have some questions for me. And we don't have anything on the Slido, so if someone has a question. Okay, let me rephrase it. Okay, let's start with the first one. Have you been using Open Rewrite or something similar? No, unfortunately, no. We aren't allowed to use open sources or any other tools like that. We wanted to. We tested it a bit, but not in our development environment. But definitely, if you can use it, it could be beneficial. It will definitely reduce a lot of time, a lot of effort. So I hope I answered the first question. Are these slides available somewhere? I'll definitely share them, and hopefully they will be available on the slide of the conference, I think. And the last one, how did you automate applying similar changes? Scripts, libs, scripts. We made a lot of scripts. After we figured out what are the patterns, what are the most repeating tasks, we started to automate by creating some scripts. Everything built in-house. As mentioned, we are not allowed to use other tools, even though we wanted to do that. Okay, anything else from the room? If not, that was it. Yes? Yeah. Yes, definitely. After I need to get away from that part. After having this experience, which for the company represented a lot of additional budget that was invested, we had to postpone it one release, so we had a lot of issues with that. The next update is already on our roadmap, and we got the promise that we will keep up to date more often than previously. So definitely something got changed for this. Thank you for the question. And thank you.